nature of roots. Nature of roots. So right the room is roots again again. Roots the x-intercepts. So we have a situation. So we can say we have different situation. 1, 2, 3, 4. So we have different situation. So pila re bolela ka nature of roots. Even before we come, let's do this. We'll discuss the quadratic formula. This one. Male x is equals to minus b plus minus the square root of b squared minus 4ac over 2a. We can put this thing further. Minus b plus minus the square root of delta over 2a. So here we discuss this nature of roots. Basically, we're discussing this delta. So get delta L is inside the square root. So we have real roots. If the roots are real, we have this. So as long as these things they touch, as long as the roots they touch the x, we have roots that are real. Also this one, as long as it touches the x-axis, we have real roots. So this you can say these roots are real and unequal. We have real and unequal roots. So we get real and unequal roots when delta is greater or equals to 0. No, we only not this. We get real roots. So under real roots, when roots are unequal, are real and unequal, it means our delta is greater than 0. Or delta number is positive because positive square root is going to be real. And then we say, if we can say now, if this delta is equals to number along or it's a perfect square, e.g. 4 is a perfect square, p squared is a perfect square, 4p squared. Anything in something even power is a perfect square. If it's a perfect square, we say those roots they are also real, unequal, and what? Rational. Then if not, if the delta is not equals to a perfect square, the roots are what? We basically real, unequal, and what?
Irrational gets a second over
In a form of a over b. Decimals. Real. So real. So here delta.
Real and equal. Graph thing is
so real and unequal. So unequal is a when delta is equals to 0. Real and unequal. Delta is greater than 0. This one you occupy this. Delta greater than 0 it govern real and unequal. And then rationally it govern again when delta is equals to a perfect square. And rational. And irrationally when delta is not equals to a perfect square. Then we have another roots that are real and equal. This one. It's when our delta is equals to 0. yabo. So if delta ya rena is equals to 0 mo ge re sa tlo ja 0 yo salang go sala x is equals to minus b over 2a because this one e ba 0 so mare e ba turning point, so go raya the turning point is on the x-axis yabo. So ke ela here re solver re kry for example maybe y is equals to x minus 2 yabo. Wa itse gore if ke di brackets tse pedi tsa tshwana ke equal roots yabo, equal roots, so we say the roots are real and what equal. Real equal roots, they are also rational, these roots. Okay, 0. So how we solve this over y is equals to x minus 2 all squared. Q how is 0. This is your p, right? That's why regular x is equals to minus b over 2. Right? So we see these roots are real and equal roots when delta is equals to 0. When is this graph exactly on the x-axis? Exactly on the x-axis. And lastly, we have non-real. So we have non-real roots. Non-real roots ke tse di sa touching the x-axis. This one are non-real. When delta is less than 0. Non-real roots reference. We just leave it like this.
When it does not touch the x-intercept.
So let's say generally the following graph. Let me write down the following graph. Here is the following graph.
As a function.
Here is the following graph. So let's say we have the graph alien so. This graph gives a f of x. This graph gives a f of x is equals to 2x plus 1 all squared plus 4. Then each sketch is like this. Minus 1 and 4. We have 0 and 6. So what are the nature of roots for this graph? Discuss the nature of roots. What is the nature of roots? So what is the nature of roots? So they are what?
They are non-real.
They are non-real. Remember? So the roots are non-real. Then what for which? Then what is about? For which values of then both a graph, mama. But for which values? Let's say this one. For which values of p will 2x squared plus 4x plus p equals to 0, have number 1 equal roots, and number 2 real roots. Remember, which values of this thing will have equal roots or will have non-real roots. Remember? So first, how can I check our equation? So you're going to use the graph. The equation is going to be somewhere, somehow, it's finally. How can I check f of x here? F of x here, f of x is equals to 2x plus 1 whole squared plus 4. Remember? Mara right tlhatlhamolola ra e bila yo bang 2 basically x squared plus 2x plus 1 plus 4 again. So yo bang 2x squared plus 4x
2
plus 2 plus 4, which is just 2x squared plus 4x plus 6. Remember? So re ka re he sane go kwala f of x like that, re ka e kwala so gore ke 2x squared plus 4x plus 6. Remember? Remember? So here it goes ka mokgwa ra itse okay, now we can interpret the graph. Ra re what are we given? We are given this. We are given 2x squared plus 4x plus p is equals to 0. Wa bona mpo re tshwana le function mare differ ka last page. So e le so o tseya this even so e le so o tseya this value, so yo ba o tseya this value, o tseya this thing ka mokgwa e leng ka mokgwa wa reng wa re wa re 2x plus 4x is equals to p minus p wa e tlisa ka mo go e shota kang gore e tshwane le ka plus 6, so wa add plus 6 ka mo wa add le plus 6 ka go rona le ke na le function which we can call it f of x is equals to minus p plus 6. No, f of x is equals to minus p plus 6. So here so we have two functions that intersect. F of x intersect the graph, which is a constant. Go get the y tse pedi, and then y it's up and down. So go get another equation, so which I can call it y is equals to minus 6 plus, which is equals to how much? Which is equals to y is equals to minus p plus 6. So now what's a this line fela. If this line e kata graph ya y 2, go ra re ke 2 roots. If e kata ha 1, exactly on the turning point ke 1 root. Then if it's a cut the graph ke non-real. O e tsamaisa line e a ke rona line a ke bitsa minus p plus 6. So if we cut, so o check the y value, only the y value of the turning point, because we change our y value. Then bar for which values of x will be real roots, equal roots. So equal roots, it must be exactly on the turning point. Or discuss that thing. Okay? So if it's exactly on the turning point, coloring minus p plus 6 must be equals to what? 4. Then you solve for p. Color p are never over 2. Then number 2, But for which values of x will this thing have real roots? Real roots, real roots, you're talking from the turning point going up.
Yeah.
The turning point is also Li equal roots is also real. As long as you can cut the graph anyway. So minus p plus 6 greater or equals to 4. Not greater than 4. Because at 4 equal roots, and equal roots alone is also, they're also real. You remember from this one, equal roots alone, they're also real. Yeah. So now always solve minus p greater or equals to 4 minus 6. So p is going to be equals to less or equals to what? 2. P is equals to 2. Yeah.
Okay. Then question here, class.
Hey, if it's less than 4, it's non-real. So if you can go against number 3, it's non-real. Non-real, you 3. When minus p plus 6 less than 4.
Less than. Because equals to
turning point. Well, that's how you discuss those things. Well. So this thing it got in another form. I don't want this form also. I don't want this form. Let me request a new page. So so you can request a new page. Kana graph kanele so graph kanele so. So we have minus 1 and 4, 0 and 6. And Mokibar with a question about for which values of x. Salvador equation here this graph nailing f of x is equals to f of x is equals to 2x plus 1 all squared plus 4 then a question would love with sanyo na mobile question but for which values of x Mokibar for which for which values of m well 2x plus 1 all squared plus m equals to 0 have 1 equal roots. Number 2, non-real roots. Over no if you look at this form, compare it to this form, a completed square. Go to equation here again. Tshwanetse ke form that equation pele ka m e tlo tsamaya tshwanetse ke form that equation ka m e tlo tsamaya so ke tlo reng first ke tlo kwala pila so ka re ke kwetse 2 ka mokgwa ba mfileng yona x plus 1 all squared plus m is equals to 0. gore go tseya m ka mo tlisa ka mo so yo ba 2x plus 1 all squared is equals to minus m, then e shota kang ka 4 gore go ba leng plus 4 plus 4 gore no tshwana ke na leng f of x is equals to minus m plus 4 minus m plus 4 minus m plus 4 gore that graph e tsamayang so yo ba y is equals to minus m plus what plus 4 whatever. This is what we have, y is equals to minus m plus 4 whatever. Then we can answer those questions, but for which this thing will have real roots. Scalable re equation as f of x is equals to minus m plus 4. Then but for which will this have equal roots? Equal roots is when it's exactly at the turning point.
Yeah.
So koloriyoba minus m plus 4 is equals to 4. Therefore m is equals to how much? 0. Number 1. Remember? Number 2, non-real roots. Yoba minus
m plus 4 less than 4.
Then so for m minus m must be less than 0. M is greater than 0. Then it's done. That's how you do this question. Check. That's how you discuss the nature of roots. So with this graph, the parabola sketch is defined by f of x is equals to minus x squared plus 8x plus 20, and it sees a point which is 6 and 32. And EF is parallel to the y-axis. And about to determine the coordinates of A and B. How are we going to determine the coordinates of A and B? We determine about the coordinates A and B.
Find the difference of two squares.
Check A. Tama go check what's happening at A and B. The x-intercept, what do you want? So go 0 is equals to what? Minus x squared plus 8x plus 20. Because at B and A, the y coordinate is 0. So ke x-intercept pila. Then robaling x squared minus 8x minus 20 is equals to 0.
We're gonna change our or is it a must?
It's not a must. You solve anyhow. You can even use quadratic formula. Anything that works for you.
No, get out more feel so I get it's concave down. So here we change it one array.
How we change? You're just solving for x. You can offer same answer. Whether we run. So the factors module 1.
10 and 2 and 2.
10 and 2. Yeah. Just that it's easy to factorize if AL is positive. So which one over minus? Minus 10 plus 2. Therefore x is equals to what? Minus 2, or x is equals to what? X is equals to 10. Okay? For the coordinates are 8 over minus 2 and 0. What about the coordinates of B? 10 and 0. So we can come here and substitute them. 10 and 0. Then we have the coordinates of A, which is minus 2 and 0. Okay. And we can go to the next question. We can discuss the next question. So the next question is determine the coordinates of D. Here determine the coordinates of D. Determine the coordinates of D, the turning point. The turning point of F. Wherever to determine the coordinates of D, the turning point of F.
There are three ways of it.
First one,
The one here, x turning point.
X is equal to minus B over 2A. So go by minus, what is your B there?
8
2A away
minus 1
minus 1. So go by
positive 4
positive 4. Then when you get F of 4, you go by minus 4 all squared plus 8 multiplied by 4 plus 20. Then it gives you how much? And you get 36. For the coordinates of these going to be what? 4 and what? And 36. Yeah. So we can put them here. 4 and 36. Yeah, 4 and 36. Straight B. And now, when we're discussing the next important aspect, we say now calculate the equation of AC. We say now that determine the equation of AC.
This one was too easy.
Determine the equation, let's say, of G. Let's call this one G. Over. For argument's sake. Determine the equation of G. Basically, if you can see the G game, G is a straight line, I guess. So what do we need to calculate the equation of a straight line? We need 2 points to calculate the gradient. I guess. So we're going to calculate the gradient P, which is going to be what? Y2 minus
y1
over
x2 minus x1
minus x1. X2 minus x1. Okay. X2 minus x1. And then we substitute. When we substitute,
6
row substitute the points, let's see. So you have 32.
minus
You have 32 minus 0. And then rather x here more c, you guys 6 minus 2. Then we get how much?
5
Why? 4 again. We get 4. Therefore, we're organizing g of x is equals to 4x plus c. You agree with me? Then we calculate the value of c. We substitute one of the points again. So we can say y is 0. We can substitute 2. Y I think is 0. Then 4. Value 4x I think y minus 2. plus c, therefore c ke 8. Well, what are coordinates of the coordinates of g of x is going to be 4x plus 8. G of x is equals to 4x plus 8. So we can put it here, where g of x is equals to 4x plus 8. We'll need it for future use. G of x is equals to 4x plus 8. And we can go further. Inside.
The questions that you ke itse answer tsa tsone. Pila mo dilo tse ke tlhakatlhakantsha ke ya hyperbola seng straight line there.
And now we'll show that now we are dealing with the lengths. For example, if they can say determine the length of AB. Check AB is in this one. It's horizontal. Or check the x values. So if it how if it's horizontal, like so check the y values to this one. If
2 plus 10.
So therefore AB is going to be what?
2 plus 10.
Get 10. Because mo 0 again. Get 10. Then distance wise is always positive.
Yes.
So we can write about 10 plus what? Plus 2, which is going to be what? 12 what?
Minutes.
So it's easier if you calculate for x. Then I was about show that EF. Then about for questioning we happy man. But no, here the vertically something important comes. So but like a question I should show that the length of EF is equals to minus x squared plus 2x plus 12 can be expressed like this. Can be expressed like this. So how determine a length horizontal as long as this thing is perpendicular. What we say? We say now the length of EF is equals to the graph that is above. Graph above minus graph what?
Below.
Graph below. At that point, so if you check more EF, which one is above? Parabola is above, ne? We're going to have f of x minus how much?
Minus G of X.
Minus g of x. Whatever. So we're going to have f of x minus g of x. Then what is my f of x? F of x again minus x squared plus 8x plus 20 minus g of x away 4x plus 8. Then we minus them. We over 1 minus x squared minus 8x minus 4 okay, plus 4x 20 minus 80 away plus 12. So this is the expression here EF. So every time it calculate the length very loads so you see the graph that is above minus the graph that is below. Sometimes if I have the x value, you substitute the x value, then you get the length. Whatever the maximum value is basically the y coordinate of the turning point of the graph. So here now what a question but determine now what a question but determine the maximum length. Calculate the maximum length. So now what a question. So we're given the expression of EF. We're given the expression of EF as x squared plus what?
Plus 4x
Plus what?
plus 12.
Plus 12. Then now what are the next question? It was a area. Calculate the maximum length. They say calculate the maximum length of EF. Calculate the maximum length of EF as well as what? The length of OG, as well as the length of OG if EF has this maximum length. If EF has this maximum length. No? So EF here in already Mosagir. The expression here the graph that is above minus the graph that is below, which is minus x squared plus 4x plus 12. Okay. So we have the maximum length. Reiterate this thing as an equation. So basically we are looking for the turning points. Yeah. So we can complete the square. So we're going to complete the square. Yeah. And then again, a here is negative. We want a negative maximum length. Program maximum. Coral graph iso. Coral maximum. So x is equals to minus b over 2a. The x value b. So what is the x value there? X is equals to minus b 4 over 2 a minus 1. Minus 1. Yung for 2. Kuro 2a. If it's going to give us the maximum length, Kuro OG is going to be how much? 2.
Yeah.
Therefore, Kuro more OG. 2 units. If this thing is going to be the maximum length. Basically, it's the x. Parking. The x value of the turning point. Then the maximum value on our then we're going to substitute 2 here. EF we'll substitute a minus. We cancel 2. So we got 2x squared plus 4 multiplied by 2 plus 12. Then we get how much? You substitute, you get 16 units. This is the maximum length. This one is our maximum, which is 16. It's like more or less the questionnaire calculus. When you hear maximum, we can also find the first derivative. Differentiate equals to 0. We're going to get 2. Differentiate the first derivative, we get 2. After getting 2, we substitute it more EF with an expression here EF. Then we calculate that thing. So that's the length. So that's how we calculate the length. That's how we calculate the length. So we can try and play along and mix this question. Let's answer a bit of before we go far. I can answer too much into that. Sometimes you want the basis here grade level. But now we can discuss this thing. Yeah, alright. For which values of x now? For which values of x? Then we can discuss those questions. We can now say for which values of x will, number 1, f of x maybe be greater than 0. Number 2, g of x be multiplied by I discussed it 2 at the go. 2, f of x multiplied by g of x must be greater than 0. Whatever. So that for which values of x is f of x greater than 0. Greater than 0, it means y value is positive. Okay? It means the y value is positive. So if the y positive value is positive, it means it's above the x axis.
Yeah.
Color yoba mokai. Yoba, let me take the yellow one. Color a positive is greater. On the yellow one. It's between what?
It's between
Color x value yaka it's between 1.
-2.
It's between -2 and 1
and 10.
and 10. That's the answer. It's easy as that. It's only inequality. Okay, substitute this inequality we're going to get the answer. The graph is already sketched. That's why we use the graph. Then the second one, but for which values of x is f of x multiplied by g of x greater than 0? For these things, here they multiply, they must give us positive. Greater than 0, it means they must be positive when you multiply them. Whatever. For to be positive, this one must be positive. This one, if this one is positive, this one must also be positive. Whatever. Or if this one is negative, this one must also be negative, because negative times negative is positive. And positive times positive. The graphs are they are both below the x-axis or they are both above the x-axis. So from this side, from this side they are all below. So our answer for this one is going to be what? The answer for this one, the first solution that you're going to get from here to here, they are all
Positive.
They are all negative.
All negative.
So color x here must be what? Less than -2. Then here feta mo hape. Again, greater 0 is not there. Color here more they are all equals to 0. Mar is not there. It's not included 0.
Yeah.
Then color here feta more they are all above. They are all above until the fita more b. Because engwe to more below and still above. So color you are happy between -2 and what?
And 10.
And 10. Or x here now is going to be like this. -2
and 10.
Between the Korea address. That's how we discuss them. -2 and 10. Then we can get more questions. We can do more questions. We can do more questions. We can do more questions. Play around. Get another one. Let's get another one. For which values of x will this thing? Let's put habit 3. F of x divided by g of x is greater or equals to 0. This guy can say greater or equals to 0. You know, less or equals to 0. So if it's less or equals to 0, coloring. Where's my yellow one? My yellow one, come back. Coloring. If this one is negative, this one must be positive because the product must be negative. Koronya ka mo loring engwe hele above, engwe must be below. Because if this one is positive, this one must be negative. Because negative divided by positive is negative. Positive divided by negative is negative. Negative divided by positive is negative. So if engwe is above, engwe must be below. So they are all below. They are all above. So at this point, they are all equals to 0. We can't put this one. Because if value is 0, g of x if ever 0 is undefined. Then g of x can be, f of x can be 0. If it mo engwe 0, then ho feta mo 10 go ya enngwe is below, enngwe it's above, whatever. Or answer na yobang x must be what? Greater or equals to what? 10. Yabo? Because ha ile mo 10 di ba 0. F of x equals 0. Yoba 0 divided by this give us 0. It's part of the solution. Then ho ya kwa any value ke be substituting enngwe positive modimo enngwe negative. Emfa answer yabo. What's what? But we tlhokomele he ka ba so. He ka ba g of x divided by f of x less than 0. Still the same thing. But answer na mo tshwanetse be yoba x greater than 10 fail. Because at this point f of x is going to be 0 here. When it becomes 0 it is undefined because it's divided.
Yeah.
Marele multiplication you know greater than 0. Marele division, this one must denominator must not be equals to 0. So you know by x greater than what? You know by x greater than 10. Well, 10 is not included because once at 10 our f of x becomes 0. Well, so it Moki is divided by f of x. You are undefined. You hear this thing even undefined. Well, then we can discuss the last few easy ones. The last few easy ones we can discuss this one. Four, f of x is equals to g of x. Then 5, f of x minus g of x is equals to 0. Don't we do f of x is equals to g of x like a point of intersection. F of x is equals to this like a point of intersection. So this one like a point of intersection. What are the answer for this one? Where the graph intersects. So they intersect here and here. Or x is going to be equals to 1, -2, or x is equals to what? 6. Whatever. So it's going to be the same answer for your f of x minus g of x is equals to 0. Whatever. It's going to be the same answer. A is the general formula that we use to find the distance between two graphs. If get f of x minus g of x, the distance between them is 0. If the distance between them is 0, if the distance between them is 0, if the distance between them is 0, they intersecting. Because the intersecting is going to be the same answer as x is equals to -2 or x is equals to 6. Because for f of x is equals to g of x.
Yeah.
Then that's all. Because they are intersecting. That's why maybe offer something like this. But for which values of x? Maybe offer something like this. Maybe f of x minus g of x is equals to 1. The difference, the difference between these two graphs is 1. What the difference between these two graphs is 1. So more the difference between the two graphs is 1. So you substitute f of x, you substitute g of x, you solve it. You solve for x, it equals to 1. Then after getting the x value, you substitute it. You substitute it more f of x minus problem. You get the x value, then you substitute again to get the y values. To get until then you get your answer.
Price maximal.
That's it. That's it.